Hello and welcome to my video lecture on derived data. So, when we talk about derived data, we're talking about the data that gets moved into the data warehouse. An objective of derived data is it has to be easy for the people making decisions to get to and use, and to be used by the applications they use for reporting. It has to be fast. Right? So, we're not going to have somebody on the board of directors clicking a button and waiting for 5 minutes for a report to pop up. This has to be fast, real time. This has to be customized data, right? So, depending on who you are, if you're using this, you're probably a very important person, and you're going to have your own data needs. For instance, here at Hofstra, my vice president, who's the vice president for student affairs, is going to have a completely different data need than the vice president for finance, for instance. It has to allow for ad hoc queries, and it has to have data mining capabilities. Did we talk about data mining yet? Data mining is a statistical analysis of data, which if we haven't spoken about it, we will. So the characteristics of derived data, we've got detailed, which is mostly periodic data, right? So there's our ODS, our operational data store. We've aggregated a lot of the information in the data warehouse for our summary reports, and it's distributed. So it either goes out to departmental servers as, talking about their data marts. So the most common data model is what's known as the star schema or the dimensional model. So let's take a look at what that looks like. First of all, right, taking a look at this should not be a startling slide for you. You've seen ERDs before, and this is using our crow's foot notation, so this should be very familiar to you. So we've got in the middle what's known as the fact table. So that is really where your big data is going to be. So that's your fact table is what's going to have all of your data in it for the most part. The dimension tables are tables that are linked by keys, and we'll talk about an example in a minute. But when you take a look at this, what should pop out to you is that if you got rid of the fact table, right, what you would have is many-to-many relationships amongst all of these dimension tables, right? If you notice the way it is now, all of your dimension tables have a one-to-many to the fact table. So if you get rid of the fact table, what you end up with are many-to-many relationships amongst all your dimensions. As soon as I say many-to-many, when you're developing a relational model, what should come to mind is an associative entity. That is exactly what a fact table is. The fact table is the data warehouse equivalent of an associative entity in a relational model. Okay? So hopefully that is clear, because when we do the example here, that should make it fairly clear, right? So we've got our products, right? So we've got all our different products. Any product we have is listed in our product table. That's our lookup table. So it's just like we would have in our relational model. We have our stores, right? So our stores would be, again, very similar to what we would have in our relational model. So those dimensions are very similar to what we have in our relational model. What's different is the period. And again, this is where our time dimension comes in. The period can be very, very complex. So we've got a period code, and whatever period code we associate to our fact table has a year dimension, a quarter dimension, a month dimension, a day dimension, could have an hour dimension. Could have all sorts of, financial year, fiscal, fiscal times, which are going to be different than calendar times. So our period table, and you'll read that in the text, can be a very complex entity in and of itself. But this period dimension should be associated with every fact table that's in your data warehouse. That is really your central dimension, is your period dimension. So let's take a look at what this looks like with real data. So for instance, we've got our fact table, which is sales. All right, so now we're trying to keep track of sales. Each sale is associated with a product, with a store, and with a period. How many units are sold, the dollars that are sold, and the dollars associated with the cost, and then we can calculate out the profit. So the thing about this is derived data. So this is summarized data. This is not your operational data stores. You can see here, it can be, don't get me wrong, but in this example, this is our summarized data, right? So we're aggregating information. So we've got what product, during what period, and what store is sold. So now you can imagine, as time goes on, how humongous this fact table can get. Okay, because we're keeping track of any particular period. So if our period is associated with days, that means every single day for every single product for every single store. If we add another dimension to our fact table, the fact table gets exponentially larger. Okay, so this is humongous. And then later on, what we're going to talk about is how you handle changes to a store. Right, so that particular store, the name of the store is Jan's, right, and they're in San Antonio. Well, what if they get bought out? What happens when their manager changes? Things of that nature. What happens when we add a new product? What happens if we change the description of a product? How do we handle that going back in time? So, as I've said plenty of times before, the time element is what makes this so much more complicated. So that ends my video lecture on derived data.